Dear students, at a part of our experiment, one of the experiments that we are going to do for AC emissions laboratory is direct and indirect method for determining the voltage regulation of an alternator. So in this experiment, you will be given with an alternator assigned to work on the alternator table. So in that alternator, you have to do two types. One is the predetermination of regulation of alternator. Other one is direct determination or using the load test to find the voltage regulation of the same alternator. In this case of predetermination, so we are using three types of methods. One is the EMF method, the second one is the MMF method, and the third one we call it as the ZPF method. So in the first stage we are going to do predetermination, and followed by that we are going to do the direct determination of voltage regulation using the load test. In this case of load test, again you are assigned to carry out the same experiment with three types of loads. So one is the resistive load, the other is the capacitive load, and again you have to add an inductive load to the same circuit, so same alternator, and you have to find the effect of voltage regulation for the inductive load also. So what is the objective in carrying out is, after completing the experiment you have to do the calculation to you find the voltage regulation using EMF, MMF. So after that you have to compare, we are going to compare the voltage regulation obtained using EMF, MMF and ZPF methods. So from which again you have to compare the voltage regulation obtained using predetermination and also with the direct loading methods. Find the difference and analyze which method is going to give you an effective way to find its voltage regulation. And also for load test you are using three types of loads, that is inductive, capacitive and resistive loads. And now our objective is analyze the voltage regulation obtained for the three types of loads and why there is a difference in the performance of the machine for different types of loads. So this is what we are going to study in conducting this experiment. So now we are seeing the circuit diagram for conducting various experiments we are going to do in this experiment. Okay, so and we know that for predetermination we are using three types of analyzing methods. We call it as EMF method, MMF method and ZPF method. For EMF and MMF method, so what we have to do is the open circuit test and the short circuit test. So first thing we have to do the open circuit test, and second we have to use the short circuit test. And these two test readings can be applied for finding the voltage regulation using EMF and MMF method. Let's see how to conduct the open circuit test and the short circuit test. And this is the circuit connection and circuit diagram, we know that. Okay, and in this case we see that the first part of the circuit we call this as the prime mover circuit, and here in this part of the circuit we call it as the alternator circuit, and this we call it as the excitation circuit of the alternator. So in the prime mover circuit, you see that there is a DC motor which I used to give a mechanical input to the alternator, and this DC motor is supplied by a 230 volt DC. And here what you have to do is give the connection, check the connection, and you see that the rated voltage is given to the motor. If the motor runs at a speed lesser than the rated speed or the synchronous speed of this alternator, you have to increase the speed of the motor using the field resistance here. Slowly cut down the resistance until the motor reaches its rated speed. So once the motor reaches the rated speed, the alternator which is coupled to the motor also runs at the rated speed. So what next comes here is you have to make efforts so that the rated voltage is developed or induced in the alternator. So what you have to do is, so now the speed is at rated speed or in the synchronous speed of the alternator. Now the voltage or the supply that to the field is very less now. So what we have to do is, so we have to increase the excitation of this pilot generator. This pilot generator is an ordinary DC shunt generator which you would have studied in the earlier semester. So slowly when you reduce the resistance, when you go like this, the pilot generator step by step it will gets excited, and the to induced voltage of the pilot generator is going to be applied to the field which is connected across it. So in each and every stage, you see that there is an increase in field current, and similarly there will be an increase in the induced EMF. So this procedure you have to continue until the alternator was able to develop the rated voltage specified by the vendor. So this you call it as the open circuit test. Now after completing the open circuit test, that means once the rated voltage is induced in the alternator, the next step you have to do is you have to go for the short circuit test. For short circuit test, so you have to bring this position to its original position, so EMF given to the field is less and the induced EMF is going to be almost to its initial stage. So that is the voltage is brought up almost to zero. So after that what you have to do is close this DPACS, that is double pole single throw switch. Close this one. So close this one, and then again what you have to do is increase this field slowly, until this ammeter reads the rated current of the alternator. So increase this field slowly until this ammeter, that is which is connected in the short circuit portion of the alternator, reads a rated current. Now the process of short circuit is over. Just take one reading, and what you are going to measure is the short circuit current and its corresponding field current value. Just one reading is sufficient to take the short circuit analysis. So this part of this type of two experiments, open circuit and short circuit, are necessary to find the voltage regulation using EMF and EMF methods. So what is the next method? Next method is I have to go for the ZPF method. ZPF stands for zero power factor method. So in this method what you have to do now is, so this part of the circuit, that is this part of the circuit should be removed, and this inductive load should be substituted in its place. So you have to remove this circuit and replace this with the inductive load. So that means the alternator is directly connected to the inductive load. So now it's over. What next? See that the alternator runs at the rated speed or in its synchronous speed. So now, so you have to increase this this field resistance, so until rated voltage is obtained here, here. Okay. Next step. So take one reading at the rated voltage. Take one reading keeping the TPSTS open. That is this TPSTS for now. Okay. So this is already replaced. Okay. So now what next is, slowly add the inductive load. So you have to keep on adding the inductive load like this. You have to keep on switch on the inductive loads. For each and every load you see that, so there will be a reduction in the voltage. So what you have to do is increase the voltage so it brought back to its original value. Increase the resistance pilot generator, increase the field excitation such that it is brought back to its original value. Now open the TPSTS. Open the TPSTS. Measure IF, IL and the new value. Repeat this process until for 5 or 6 readings. Repeat this process for 5 or 6 readings. So that is sufficient to do the experiment for open circuit test. Now coming to the load test. So what we have to do now is again replace this part, inductive load, and replace this with the load. So first we are going to add a resistive load. This may be a resistive or inductive or a capacitive load. Now first add a resistive load to this alternator stage, to this alternator circuit. Now resistive load is added. So see that the rated voltage that is available across these voltmeter is always a rated voltage. See that the voltage is always a rated voltage. So rated voltage. Now what you have to do is close this TPSTS. Close this TPSTS. Now keep on before closing this, take one reading at load condition. Now keep on adding the loads. For each and every stage. Measure IF, IL and the terminal voltage VL. Sorry, okay. Now measure the field current, load current and the terminal load voltage available. Repeat this procedure until you reach the rated current here. Rated current until it reaches the rated current. Okay. Now for inductive load, replace this circuit with an inductive load. So start from low load, keep on adding the load, and each and every addition of load measured the ammeter in field current, for field measuring field current, ammeter that measures the load current, and the voltmeter that measures the load voltage. Repeat the same procedure for the capacitive loads until you reach the rated current. Now you know what we studied is, so we know how to conduct an open circuit test by keeping TPSTS open, how to conduct load test, so short circuit test by shorting the 3 windings of the alternator using this TPSTS, and we know how to conduct a ZPF using the inductive load, and how to connect load test using resistive, inductive and capacitive loads. So these are the 3 things. So after completing the experiment, so compare the effect of power factor. That is, you have to do the calculations for various power factors, that is for leading, lagging and unity power factors, and the influence of power factor on the voltage regulation using the 3 predetermination methods. So compare the results of EMF, MMF and ZPF method. You see that the 3 methods are applied only on the same machine, but still you find that in one method voltage regulation is more, in one method voltage regulation is less, in another method you can find the voltage regulation is somewhere between the higher and the lower values. So why there is a difference between the calculations? What causes the error? And why do you want to go with EMF, MMF and ZPF method instead of these errors? Why it is so like this? So find the reason behind the difference and justify the reason behind the differences. And similarly, after that, so compare the voltage regulations of inductive, capacitive and resistive loads, and what causes the voltage regulation, and what is the nature of the voltage regulation, and what causes the difference in behavior of the machine with respect to voltage regulation for the 3 different type of loads, and identify the things based on the theory what you thought is taught in the class. Compare the indirect methods, that is ZPF, MMF, EMF methods with the direct method, and which method is finds more closer to the direct method, and which indirect method gives an accurate results. So if so, what is the use of the other two indirect methods? So these are some of the things you have to justify while doing the experiment. Okay, do it. If any doubt, please contact me. Thank you very much.